Thank you so much for the introduction. Okay, so today I'm going to talk about, again, pre and post harvest factors affecting lenticel breakdown disorder. And First of all, we know a lot about LBD, and that's the acronym we use for lenticel breakdown disorder. It's been on our apples since the late 90s and early 2000. And since then, Eric Curry and Gene Kufferman, they did a lot of work throughout the 2000s, 2010 and 12 and more, trying to understand this disorder. And today we know that, of course, it is a problem in many areas in the world producing apples, and mainly those apples grown in dry and hot environments. There is a cultivar susceptibility. So Gala is the most susceptible cultivars. I would say Fuji is also very susceptible to lenticel breakdown. And among Galas, Royal Gala is one of the most susceptible one. Fuji, the BC2, seems to be the most susceptible one. And after that, any variety can get it. We've seen it in Granny Smith, Golden Delicious, Red Delicious, and others. And the characteristic of LBD is that symptoms appear after packaging most of the time, and that is 12, 48, 72 hours after processing. So before I started a project that I'm going to show you results today, we knew a lot about LBD already. And because of this early research done and transferred to industry early on. So the first thing we have to consider with LBD is we have to get the symptoms right. We have to identify the disorder right. So early on, Eric Curry and Gene and other people, Elmi Lotze from South Africa, came up with this chart showing different lenticel or pit issues in apples. And so then you can differentiate them among them to actually take the measure and the control that will work for the symptoms you're seeing on those fruit. So here you have the lenticel breakdown. Looks pretty similar to lenticel blotch pit, and somewhat similar sometimes with heat injury, blister spot, and calcium burn. So all of them are all different disorders and defects that are managed differently. So on your right, you see those pits or those lenticels affected on Gala, different severities. They look different on different background colors and skin colors. And so that can be really misidentified a lot of the time, especially in the packing house. Here I'm showing you a lenticel breakdown, and I'm going to go with a semicolon on Cosmic Crisp, WA38. And here, the first thing to ID this disorder, we had to get it in the lab, look at it closely, and peel it, because one of the characteristics of LBD is that you don't see the flesh affected, like bitter pit. And then looking at closely, we saw the lenticels were not the only ones affected. So some of the lenticels, yes, but other areas surrounding lenticels also. So then we left it at room temperature, because after packaging, we would get more LBD 24, 48, 72 hours after being packed. And in this case, we didn't see an increase of some of those damaged lenticels up to 14 days at room temperature. Well, it happens that those apples had some lenticel breakdown, but also they have another type of stain that we have seen in Honeycrisp. And since Honeycrisp is the mother of WA38, then this is also mixed with the lenticel issue that we were seeing in that packing house, and we had to ID. So this is an important point. In here, I'm just showing a close-up of a picture where there was a stain not in a lenticel. So that's the first thing to do. Correctly ID the disorder and the pits we're seeing on the fruit surface. Now, what do we know again about how does it happen? First of all, we have to go to lenticels. They're non-functional stomates, so they're openings on the fruit that those stomates are non-functional anymore, and those lenticels, and as the rest of the fruit needs, it gets covered by cuticle. And cuticle is an active organ that responds to fruit growth and the environment of the fruit. So usually the cuticle as fruit grows, you see cracks of lacking cuticle on top of the surface of the fruit, and those cracks need to be filled, as well as lenticels, which are openings on the fruit. And so in hot and dry environments, the growth of the fruit it's high, and then sometimes those epidermal cells are not covered fast enough. So those get damaged, and you can see that from the micrographs on the right. And so they get damaged, and then you can see that those openings then lead to damaged cells and then accumulation of anything that goes on the fruit. Crop protectants, pesticides, nutrients that you would apply foliarly, and all of that gets into those openings and into those epidermal cells below the cuticle. Of course, we're not really sure how the dynamic of the cuticle in a hot but a humid environment. And that is something that it's an organ very active, and the platelets are filling up the holes and the cuticles and the cracks on top of the fruit, and that happens all the time in different ways. So then again, when we think about LBD and thinking that we need those lenticels on those crack covers, there is some work done today, but that it's already published. Would the foggers or overhead sprinkles 1 or 2 weeks prior harvest be good for the fruit? Because humid, promoting some of the cuticle development. So that's something to go into. And what about the interaction between a low relative humidity and the calcium application? That might also be affecting the damage to non-cover lenticels, epidermal cells below it. So there are some unknowns that we are seeing and probably affecting susceptible fruit or making fruit more susceptible to get damaged post-harvest. So again, this is just to show you on your left, there is a figure there from Curie area. There was a good correlation between the number of lenticels on the surface of the fruit, so lenticel density, and lenticel breakdown. But it's really the more lenticels, the more openings, the more lenticel breakdown. The cuticle, when it does not provide enough coverage to epidermal cells, then you get all abiotic stress, pre-harvest, high irradiance, low relative humidity, cause dehydration stress. And so they have found that dehydration stress 3 or 4 weeks before harvest will lead to more lenticel breakdown post-harvest. Now, I did with Eric, was long at 2008, we worked with some coatings in the field, and we coat the fruit on bins right after harvest, prior being moved to the packing house. And we did see a reduction on LBD incidence. That time was EpiShield, 2.5% concentration. We saw a reduction compared to the control. And then also we saw that was the effect on incidence and severity. And then on your right, you can see what a coating does, right? You have all the cracks on the control, but then all those cracks are covered with this coating on the fruit. And if you store a fruit with cover cracks and cover lenticel, then you're protecting the fruit to the packaging process. which is critical for the development of this disorder. So then another group of factors, there are risk factor for fruit and affecting susceptibility. Besides cultivar, the harvest maturity. So it is well correlated that more mature fruit at harvest, more LBD afterwards. And more LBD at the beginning of the storage season on a susceptible fruit, probably more LBD as the time in storage goes by. And I'm going to show you some evidence of that. But another thing pre-harvest that we always worry about, because it has a great effect over fruit quality overall, is the mineral content. But in this case, it's really more of an indirect factor because it hasn't been directly correlated with LBD incidence. Of course, if you have an unbalanced piece of fruit, you will have less storage potential and more problems on that fruit. And here, the work done here in Washington by Curry in 2003, you can see that fruit with high LBD and Gala on the top and Fuji on the bottom will lead to unbalance between calcium and the rest of the cations. Potassium, magnesium, and nitrogen. So when that balance or when that number is high, so less calcium in relation to these other nutrients, you get you see that more on a LBD susceptible fruit. We did not see that in Chile, as you see on the right. Healthy and with LBD fruit, and they're not. All of those ratios are much larger than the ones seen in Washington. So differences between growing environments too. Okay, I told you there was a direct relationship between harvest maturity and LBD. Early on, that was pretty clear. Here on the top figures, you see that as starch index, the starch degradation index go up at harvest, you get more pitting or more lenticel breakdown. And on the right, the less firmness at harvest was correlated with less marketable fruit. So more LBD on that fruit. And again, harvest 2 on the bottom, the later harvest will lead to more LBD, and of course unpacked fruit, because that's the one that develop LBD the most. Okay, so now we have a susceptible piece of fruit or a susceptible variety, and today this is what Washington packers do, and it came from that work done in the 2000s. First of all, the fruit temperature versus dump tank temperature needs to be low, the difference, right? So you have to reduce the difference, the temperature between the fruit and the water when it reaches the packing line. So if you have cold fruit, you should wait for that fruit to warm up a little bit to go up to ambient temperature. Well, not really, because you would have to wait too long, but at least to reduce that difference with warm water on the packing line. Avoid overdose of soaps. Use soft brushes or no brushes in the case of Gala. 1-MCP has not shown benefit or be increasing LBD. So there's not enough evidence to say that 1-MCP does not or helps LBD or it's detrimental to LBD. What we know, and it's still real, it increases over time in storage, right? Because ripening and then ripening advances, and the more mature we harvest that fruit, the faster it will ripen in storage. So if you have a susceptible lot and you're seeing LBD after 3 months of storage, you shouldn't wait until 6 months to pack that fruit again, or even 9 months here in Washington. There is no enough evidence to target coatings or wax. They have no effect on LBD. But at that time, they saw a great effect of pre-sizing. And so during the 2000s and after that until recently, they avoid precising here in Washington. Although in Chile, they precise everything. And so you will see maybe why this is happening. Okay, this is more evidence published in 2000s. On your right, you have the water temperature. The warmer the water temperature, plus soap, plus wax, but it's basically the temperature of the dump tank increases the average number of damaged lenticel per fruit. On the left, you see packaging steps, and so the highest number of damaged lenticels come from brushes, wax, and soap only. So this is how those previous recommendations came about with all this research done in the early 2000s. But we still have LBD today here in Washington. And it's actually, of course, appearing in other varieties and newer varieties. And they're just worried about it. And Gala, of course, which is the most susceptible one. So in 2020, I started a project. It lasts 2 or 3 years. I'm missing 1 year there. To study the effect of dump tank composition on lenticel breakdown disorder, because we already knew the pre-harvest that it's multifactorial, but we know what causes it in the field. We're not sure about the combination of those factors, but we know it comes from their Gala susceptibility. And so now we wanted to study a little bit more the packaging process. So in this case, we got commercial lots of apples. So all this fruit was packed at the packing house and stored at the packing house. And they were precise. There were lots that were precise and then packed, commit to pack. And there were lots that were only packed. We have one lot here, the 6780, that was packed in 4 different times after harvesting in August. Okay, these are all Gala. So then it was packed in October, November, January, February. So we were super lucky to get the samples from all these times from that different lot that was pre-sized and then commit to pack and each time of those time after storage. And then we actually, to develop or look at the development of LBD, we rated that fruit grade after 24 hours of being packed, 96 hours of being packed, put that fruit back 1 week in air, and then take it out and evaluate 7 days later. And this is just to simulate what the industry does, right? After the fruit is packed and waiting to be shipped and then shipped, it could be a week that goes into a refrigerated air, only waiting to reach the supermarket. And so this is what we did. After the fruit was packed, we took 3 replicates of 100 fruit each, and prior processing and post-processing the same. And also we got water samples in all water sections from that packing facility. Here, I'm just showing you some of those water bodies, flumes inside the line. As you can see here from the pictures, they all look really clean. At least when that fruit, the first lot, was processed. Then you see, well, the one on the left is not. There is a turbidity there, right? And definitely on the other pictures. But you can see the lot coming through the line and placing on bins when in the case of precising. So what did we look at in that water? Well, we looked at everything: metals, minerals, pH or P, conductivity, temperature, turbidity, COD, free chlorine. We looked at everything. We got triplicates from every water source, flumes, precise, and then looked at all these minerals in a lab. Okay, so these are the results. And we took samples every time the fruit, all these lots were processed. So October, November, December, January, February, and then January for another lot. And here you see the sequence. So flume 1 is the dump tank. Then it goes into a second flume, and then the third flume, which is the pre-sizing. And just focus on the ones that I highlighted in green: turbidity, calcium, and phosphorus. And here you can see that from flume 1, oops, I don't know why it's going on. From flume 1 to pre-size, you see a decrease on turbidity. Okay, so which you would expect, right? Because all the fruit goes into the dump tank. That's the first water that it hits, and it cleans bins and it cleans fruit, and it gets dirty really, really quick. And you can see that on turbidity values. But also you see that on calcium accumulation, and you see that on phosphorus accumulation. And you see, of course, in the rest of the minerals, potassium, sodium, and everything else is higher at the dump tank, and then it goes down as the fruit moves to the rest of the flumes. Okay, what did we get? So here is the lot that was pre-sized in October, and then it was packed at different times. So November 5th, November 12th, November 19th. Take out the one that's circled red because that wasn't pre-sized, but it's the same lot. January 26th, February 2nd. And what you can see here, pre-line or prior going to pre-size, on top you see the LBD incidence after 0 hours, 24 hours, 96 hours, 1 week of air after 1 week of air, and 1 week plus 7 days at room temperature of being packed. And as you can see, in the fruit without processing, you will see some LBD development as time goes by after packaging. Prior packaging. Room temperature, same conditions as the one that were packed. Pre-size, you see an increase, but it's not as bad in October. Look at November, 3, 4, 15, 21, 24. November 12, up to 23. November 19, up to 49. From January, up to 64. Okay, so when you see the graphs on the right, you see, first of all, that LBD keeps developing at room temperature, and with the cold week, simulating the cold chain, and then the supply chain keeps going up on this susceptible fruit, on fruit that was packed. And on the right, you see the difference at each date that fruit was packed between pre-packaging and post-packaging LBD. This is a susceptible lot, so you will get LBD prior packaging, so on those bins. But you will see a much, much larger amount of LBD on fruit that has already been packed. These are different lots, the same situation, and here I'm highlighting those lots that pre-packaging had no LBD and post-packaging had LBD. So definitely packaging in fruit that doesn't have any LBD prior packaging, you can see LBD development. Of course, it's much lower than a very susceptible lot. So in all of those situations, you see an increase as time goes by during the supply chain simulation of that LBD incidence. Okay, so just to get the maturity out of the way of the fruit at harvest, these are the numbers of all those lots, including that one that had 64% of the fruit with LBD after packaging. They look pretty similar. They all were treated with 1 MCP. The starch are all around the same value, so we couldn't explain that differences in susceptibility of the different lots just looking at maturity at harvest, especially because 1 MCP is being applied. So at the time of packaging, although that fruit, there was no statistical differences between fruit maturity on those lots. Now, to look at the minerals on the water, which one is being responsible for LBD? We use the LBD incidence differences difference, which is subtracting the incidence post-process with the incidence pre-process to actually nail down and see the LBD attributed to the packaging conditions. We did a multivariate analysis. We plugged in all the lots in terms of, and then the difference in LBD incidence, all water analyses, and only the most relevant ones are shown in this graph, and the highest level during the process, okay? And so we actually saw 4 different groups here, and what is the label in each of those 4 clusters are the date, the LBD difference, and the lot number. So 2670 is the lot number, process December 7th, LBD difference 0 in this case. So we have 3 different clusters, okay? So, 4 different clusters. I want you to remember that. Okay, here are the clusters, right? So on the bottom, the x-axis here, we have cluster 1, cluster 2, cluster 3, and 4. And another thing I want to mention here is cluster 1 has all the lots with the highest LBD incidence. So the 64%, the 47%, 46.7%, 33%. Cluster 2 has the 48.2% and 31%, so also high, but not the highest. And 3, the lower incidence, 0.8, 4.9, 3, 3/4, 1.9, 0.08, and the 4 again, a low, 2.2, 1.9. So what did we see? So cluster 1, which had the highest LBD, had very high phosphorus on the processing. Cluster 2, low phosphorus, but high boron, high calcium, high potassium, okay? In cluster 4, also low of everything except calcium. Another thing I want to mention, cluster 1 and 2 is fruit that had been precise and then pre-pack, commit to pack, so twice exposed to water minerals, okay? Free chlorine, cluster 4, one of the lowest LBD, had very high chlorine. The rest of the clusters or the lots represented in those clusters, low chlorine. Okay, magnesium high in 2, 3, 4, but low in cluster 1, which had the highest LBD incidence. Okay, so these are correlations between the minerals and the incidence of LBD, and you have a very great correlation, 0.72 between the LBD and phosphorus. So the higher the phosphorus on that processing water, the higher the LBD incidence. The rest of the squares are not very great, so the one we're focusing on is on phosphorus. Okay, now where does that phosphorus come from? Nobody knows. The pre-harvest people at the company said, oh, we don't know. We don't apply phosphorus, so nobody knows where the phosphorus comes from. But they're not going to, we think that, it has to come from pre-harvest applications, but because there is no phosphorus post-harvest during packaging. So yes, mineral nutrient application, foliarly, fungicides that have sometimes minerals can have an effect on LBD development when it is not removed or from the waters that fruit is processed on. So some of the final remarks here: fruit from all lots develop LBD symptoms after 1 week in air storage during transit, after being packed or pre-sized, including the least susceptible fruit. LBD kept increasing after 96 hours at room temperature, and it was the highest after 1 week in air, so cold storage, plus 7 days at room temperature. And this actually, the literature before said 72, 96 hours, and some people at the packing houses will tell me, well, it reached the market where we're sending the fruit, and there is much more LBD than the sample we kept here at the packing house for 3 days. And yes, of course it will, because a susceptible lot, it will keep developing LBD afterwards. Okay. Phosphorus accumulation in the processing water was positively correlated with LBD incidence. Calcium, boron, and potassium may also be playing a role on it. Okay, so sanitizers, the next question. People here don't want to put chlorine because they think that it's actually causing LBD. So this was an important one to nail on this project. And here you have different water treatments. And the conditions of treatment application here is it's simulating the waters in the packing houses. So the one of the treatment was 500 COD, chemical oxygen demand, water only, and the formula is silk loam soil in it. Okay, when it's water only, it's just silk on the water, simulating 500 ppm COD. The next treatment is that water, same water, plus free chlorine, 50 ppm plus 5% of phosphoric acid to adjust pH. And then 500, the next treatment, 500 ppm COD plus PAA, peroxylic acid, 50 ppm. Okay, so the COD formula is on the right, the loam soil, unsweetened apple sauce, which simulates what it is on the packing houses here. And the use of 3 commercial gala lots. These are the results. No significant differences in LBD incidence or severity across lots or treatment, but there was a difference in LBD, an increasing amount of LBD over storage time within each treatment. So once again, chlorine or PAA has no effect on LBD development. We have this work has been published. It's in press. So when I'm ready, I can share with you the article. So besides the final remarks I already told you, the next two are high free chlorine was not correlated with elevated LBD incidence. And so it is okay to use the optimal dose of chlorine because we need that food safety during packaging. And the other important final remark here is you have to manage the water in the packing house, either filtering it, which would be an alternative instead of replacing it each time or after a certain amount of bins being processed, because it's critical when processing susceptible fruit. And it's something that here in Washington, and I'm going to say part of Chile because we did change practice in some of the packing houses over there, but here the waters in the dump tank are really, really bad. They're really, really dirty. Filtering systems are very expensive, and replacing water has a cost, right? And so, but something needs to be done if you're having too much LBD, which is high costs and less revenue for the grower at the end of the day. All right, thank you very much. I don't know how much time I took, but I'm done. I'm ready for questions. Thank you for the invitation.